end. So that's why we use it, and what that ends up meaning is that 2 digits of hexadecimal actually represents 1 byte. So if you have a number like 2A in hexadecimal, what you're really representing is the byte that looks like this. 00101010. So that's a basic tutorial. I don't know if Steve wanted me to cover anything else that you thought might be interesting to mention.
No, I think you pretty much nailed it. So.
Cool. So the next thing that I wanted to show before we really get into this is how we got ROMs to edit. So we have a device called the Retro. It's a pretty cool piece of equipment. You can order it from, I believe the address is retro.org. This is the box it comes in. And what it has is a Super Nintendo and Genesis port, and you can take your cartridge and pop it into this thing, and you open up your window here, shows up right here, and all you got to do is hit reset once the cart's in there. When you open it up, you can just take this ROM file, copy it off, and you're basically ready to start messing around with it. One thing I figured out is that what you want to do is take off the read-only feature. That will be on there by default. So if you don't do that, you won't be able to edit anything with it. So that's that. I already have all the ROMs that I'd need in a folder, so that was just kind of a demo of how we got ROMs off. So yeah, let's go into Super Mario World. Actually, I'll keep this up for now. So the tool that I use most extensively in doing this is called Geiger. We have the link to it in the article if you want to download it. It's basically SNES 9X with nice debugging features. So what you want to do is crack open your Super Mario World ROM here. You have this nice debug console where you can set breakpoints on certain registers. You can actually take a look at the hex of this ROM. So this is all the instructions that make up Super Mario World. And what we want to do is figure out a way to get this ROM to run in 480i. So the next thing that I'll pull up here briefly is this SNES development page. It's a great website for figuring out how the SNES works. Two kind of important things that we'll touch on here are the reference manual for the assembly language and the registers. So if you go through this, you can kind of get a look at what every register on the SNES is doing. The one we care about is right here, the screen mode select register. It's 2133, and you can quickly jump down to that and see exactly what this 8-bit register does. So you have a couple of unused bits in there, but the most important one is this least significant bit all the way on the right. That determines your screen interlace. And when that's set to 0, you're going to get a 240p coming out of your console. And when you set it to 1, it'll be 480i. The one caveat about that is what we're doing is not real 480i. By setting this bit to 1 and kind of leaving everything else as is, it's just taking the data and bouncing it between the odd and even lines, and that's not really 480i. That's a goofy hacked version, but it's 480i enough that it tricks the TV.
The sync patterns that it sends out of the console are 480i. So
Yep.
when the TV reads it, it knows it's 480i.
So in a game that's really doing 480i, they're going to be using BG mode 5 or 6, which actually has a screen height of 448 pixels, and so it'll be alternating full screen height data back and forth between the two lines rather than just bouncing the same data up and down. But that's kind of beyond the scope of the point of this. Just thought it was worth mentioning in case anyone had a question about that. So what we're going to do is try to change this register and set the least significant bit of that to 1 instead of 0. So we'll come back to that reference in a bit. So what we're going to do now is set a breakpoint, and what we want to do is look for that register in Super Mario World. And I just check all these, and if you reset the game and hit run, it's going to stop as soon as it hits this store 0 in 2133 command. So this is probably a good point to kind of talk about assembly and compare that to the hex that's kind of living underneath. So let's step through a few lines of code and we can talk about that. So here's a bunch of instructions that occur after that store 0 in 2133 command. And you'll notice they all are accompanied by a set of hex. So some of them are 3 bytes long, some of them are just 2. When a programmer is sitting there writing assembly, which they'd be writing the stuff on the right here, that's actually translated by the assembler into just hex codes. And the way that kind of looks is, let's just grab some stuff here. What you do is you'll have an opcode at the beginning. So for store 0 2133, it looks like this. And this is called the opcode. And that specifies what action you're going to take next. And associated with that is a length of bytes that it's expecting to read as part of what to do with this operation. So you would never see 9C followed by 3 bytes instead of 2, because that's how the computer knows whatever comes after here, that's a new opcode. That's going to be your next operation. And so if you bring up this reference list, you can actually take a look. This hex column here, these are the operational codes for any assembly command you want to do. So these two things are equivalent. 9C 3321 means store 0 in register 2133. 8923 means load the hex value 23 into a special place called the accumulator. So now what I think is probably worth doing is actually talking about using the accumulator versus just using this store 0 command. So the store 0 command is kind of an unusual piece of code. It's really just a simple way of doing something. You have kind of this register 2133 out here, right? And the store 0 command just lets you take this hex value 0, which is pretty common to use, and just plop it right in there. But that's not typically the way things are done, because most of the time you're not just storing zeros in registers. It's pretty boring. What you have is this thing called an accumulator. And a lot of times you'll do a bunch of math to result in some value here, and that will get ported over here. But you also have method just called load A that loads a value into the accumulator. So if you want to do anything besides plop 0 in a register, you're going to do a command like load A 33, for example. 33 with a $, meaning it's hex. So that value will go into here, and then this next command, store A, takes whatever's in the accumulator and puts it in the register that follows. So we want to put 33 into 2133. We would load it into the accumulator and then do a store A into 2133, and that looks terrible, but you get the idea.
So the accumulator, like in general with all these types of computers, is just like your temporary workbench where you manipulate stuff, and then when you're done with it, you store it out somewhere. And we're doing a very basic thing, but we're doing the same thing. Exactly.
Yep, cool. All right, so that should be enough to really get into how you hack Super Mario World, which is that if you look here, we're storing 0 into 2133. What we really want to do is store a value of 1 into 2133. That will actually put 1 in that first or least significant bit that I mentioned. We can't do that in this kind of command. So what we want to do is find somewhere else that we could do that. In our article, we talk about how you could jump to a subroutine that you create, do a bunch of interesting things there, a lot more complicated than what we're going to do here if you wanted to. But that aside, you can read all about that if you want. We're just going to go straight to doing the Game Genie stuff because for the sake of time, I think it'll just make more sense to go straight there for now. And the thing with the Game Genie is you can only overwrite 1 byte at a time. So, or 1 byte per Game Genie code, and we have 5 of those to work with. So we want to be kind of smart about how we do this. If you look at this sequence of commands that I stepped through here, you'll notice that one of the registers, which is 21OB, is actually just getting 0 stored into it. So this sequence of commands, load 0 into the accumulator and store it into 210B, is equivalent of just writing a store 0 into 210B. So what the really efficient way to get Super Mario World to run in 480i is to use this kind of inefficiency here and switch things around. So what instead we want to do is here in the code, we'll use this place, change out the 33 byte to be a 0B. So that's where we'll take care of storing 0 into that register. And then down here, we will flip this load A 00 to do a load A 01. So that's another code to change that byte. And then the third code we will use to change this last byte to store the 01 into 2133. And then we should be done. You can run this code until the next breakpoint, and you'll find what happens with Super Mario World is that this is kind of like a routine that gets called multiple times through the code. There are other games that, as I went around hacking, that actually don't do this kind of very efficient thing of writing a block of code and calling it anytime you want to set registers. Instead, it'll have multiple places throughout the code where 2133 is getting set to 0, which means you have to kind of go through all those places and fix it to set it to 1 if you really want the full game to be run in 480i. Otherwise, you know, you fix one place, you set it to interlace mode, and then a little bit later in the game, a different piece of code is going to run and set it back to progressive. So that's just something to keep in mind. But fortunately, here, this just this single place.
So the reason you're able to get away with this, right, is because this is just like a initialization routine, and they're just going through a bunch of things, and the order doesn't matter. So you're able to throw the 210B up top of this block, and then do the 2133 later, because it didn't matter what order it was in.
Right, and this is kind of common among all the games that I've really seen, is that all these registers in the kind of this 2100 to 2200 range get all set at the same time, and it doesn't matter what order it is. It's just kind of this one big function call that sets all these video processing and other registers and does it in one chunk and then moves on. So now we need to go about changing these values. So if you take a look here, this is the location on the ROM where this is all happening. 008A79. That's where on this ROM this piece of code lives. So you can actually scroll through here if you want it all the way down, but it's kind of a long way to go. So what I typically do is I just take these three digits here, and I'll pop them right here. And I like to leave that last digit as 0 because it makes it more convenient for the ordering of these things, for this first digit to be the 0 digit. So 8A79, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your 9C3321. And then you can do the same thing if you want and find these commands. The point is, you'll need to do a little bit of counting to figure out where the byte is that you are trying to change. So 8A79 refers to where this 9C is, but we don't want to change the 9C, we want to change the 33. So that's actually living at 8A7A. So let me open up a text document here. And the first byte that we want to change lives at 08A7A. And we want to change that to be a 0B instead of a 33. So what this is going to do, we'll change this command to be store Z21OB. Next thing we want to do is fix up this load A00 command. So A900, that starts at 8A8E. So this next byte here is 8A8F. So we'll jot that down, 8A8F, and we want to change that to be a 01, so that our new command looks like load A01. And then right below that, we want to change the 0B byte, which this command starts at 8A90, so that will be 8A91 that we're going to change to be a 33. Cool. So the last kind of thing we need to do to get the actual Game Genie codes that accomplish that is load up this program called the Game Genie Code Converter. And you have a few systems to choose from. We're doing a SNES game here. And you can just plug in each of these three kind of code things that I've written out, this hexadecimal notation, and you plop it in there, you get your code back. So jot that down here and do the same thing for these other ones.
I didn't know it was going to be so much copying and pasting. This is awful.
Well, normally I'm sitting here writing these out on a piece of scrap paper that is a giant mess, and then I have to decode it later because I don't remember why I was writing what I was writing. So this is actually probably a more efficient method. All right, so in the article I actually talk about how I kind of check that these codes work before I go mess around with them on an actual Game Genie. There's another tool for the SNES called No Cache SNES. I like this one better because you have a nice inspector of kind of all your registers. So with this one, if you load up the Super Mario World ROM straight away, you'll see that this interlace bit is not set. Alright, so now we want to patch the ROM with those Game Genie codes. So off to another tool, which is the Game Genie guy. We'll select our Super Mario World ROM and we'll put these codes in there. Oops.
Does this one let you do infinite codes?
Yeah, this will let you do as many as you want.
Okay.
Yeah, which is not not true of the actual Game Genie. But I mean, if all you care about is making kind of a hacked ROM and throwing that on an EverDrive, that's a different story. So once you put those in and press patch, it's going to drop a new ROM with GG appended on the end of it in your folder, and I'm going to load that one up.
You know when you gave me the EverDrive back and I looked at your folder with all your stuff on it, I thought the GG was GG, good game, it's all done. I didn't realize it was
Game Genie, yeah. So I load that one up. You'll see right away that this thing plays it in kind of a half screen. It's kind of how this emulator interprets and interlace content. But most importantly, you'll see that this bit 0 is now checked as being turned on for interlace. So yeah, that's kind of how you come up with these codes. You can take these codes, throw them on a real Game Genie. I don't really have the setup here to run my Super Nintendo into the computer and capture me doing it, but there's a video of me actually messing around with that on YouTube already, so you can check that out. So yeah, how's the chat room going there, Steve?
I don't know, I'm not paying attention. Voltar's causing a scene again.
Oh jeez.
Yep. Well, that's why he was invited, right?
Yep. So yeah, I mean.
Oh yeah, I had a question about the patcher, the Game Genie patcher. Wasn't there a case with one game where you made a boo-boo and the patcher worked, but on real hardware it didn't?
Are you referring to NBA Jam?
Yeah.
Yeah, okay, so that's a good point. We should talk about that. That you can actually kind of see it in this folder. I have a few NBA Jam ROMs. The reason for that is there are actually different revisions of some games, not all. But NBA Jam is one of them where, depending on when you bought your cartridge, it could have totally different code in there. And so you can spend a bunch of time coming up with Game Genie codes, and you go run it on your cartridge, and it doesn't work. And that's one of the possible reasons why is if you develop a code for the version 1 of the game and you run it on version 1.1, the code might be so different that you're just not doing what you think you're doing.
It's one of the reasons why you dump your own cart.
Right. Yep. That way you know exactly which version of the ROM you're working with. So that's that. Is there any questions in the chat that people have before I kind of run through anything else?
But my question was actually not related to that. It was there, you had an error where your memory banks were wrong, and the patcher still patched it, but the Game Genie was not able to do it on the fly until you fixed the error. Do you remember that?
No, I'm not remembering that. Which game was that on?
That was NBA Jam. You had a code that it was not working on the Game Genie. It worked on the EverDrive because you ran it through the patcher, and you realized because you never looked at the bank address. You just looked at the four hex values.
Okay. So are you talking about the mirroring problem?
Yeah.
Yeah, that's so. We were talking about this last night a bit. The SNES, for a lot of games, has this kind of mirroring feature where this code lives at 008A79 on the ROM. But it also gets mirrored, and you can actually see, just based on this default, how this hex editor opens, it's mirrored at this 80 start. And from what I've read about this, of course, take that kind of with a grain of salt. I don't always trust everything online, but there are two places. This shadowing of the code down at the lower address is done so that the Super Nintendo can, different components of the Super Nintendo can access the same code easier, because not every piece has access to the same part of the code on the bus. I don't know if I'm fully understanding of how that works down at the hardware level, but the point is, when I'm doing codes, I go off of these numbers here, the 00 addresses, not the 80 shadow. Does that kind of cover what you wanted me to talk about?
Yeah,
there?
I guess, yeah, my point was just that whenever you do stuff like this, and you're developing or hacking or anything like that, you always want to check on the final hardware. Like, you always want to do a real check. You don't rely on emulators and tools like this 100%. You always should do a test, because there's always some weird, goofy thing that pops up.
Yep, that's exactly right. It's kind of how we discovered this whole thing. Was the code's not working, and then when I went back and looked, it was just a confusion of these two banks. So cool. I don't know if people in the chat have a preference about what I do next. The kind of other things I wanted to cover was Mega Man X is an interesting use case because the game never actually sets register 2133. It just takes liberty assuming that it's going to be 0 when you turn on the console. I can do a game called Street Combat USA, or maybe it's just Street Combat. That game's interesting because it has a portion of the game that's already in 480i mode, so I can fix it, go in the opposite way, and make that a 240p game. Or I can do Genesis, which is quite a bit different. So I don't know if there's a preference there. I can just go onward.
No, it's not much action on the chat. Just Adam is asking when he can buy an RFizer. And Volter wants to know when we're getting Tiger Electronics component cables for those handhelds.
Someday.
So one day when it's nostalgic enough.
All right, so I don't think I'll go over any more of the actual creating of a Game Genie code using this and patching. I mean, it's the same thing, so it's kind of a waste of time just to keep doing that. But I can kind of more quickly just run through some interesting cases with code, and because we've already gone for like almost 40 minutes here. So let's load up Mega Man X. So breakpoint's still set. You run this thing, you're not going to come across anything except for this kind of command here. And that's kind of it. And so what I do to get around this is I actually look for places where other interesting registers are being set, similar ones. So you can just throw in some random ones that are in the same region. Throw in 210B because that's the one we flipped last time. And then there's, whenever those 2000 level registers get set, a lot of times these 4200 level registers also get set. So one thing you could do is just look out for these registers. Yeah, go for it.
Yeah, so you're just looking for spots where it's likely that the SNES is doing initialization steps.
Yep.
And you're trying to smuggle in your code somewhere in there.
Exactly. So we've hit kind of one place here, kind of a clue. This 8912. So let's go to So right here is where, let's see, 8912. It runs, okay, yeah, it stores something into 210B right here. It's actually storing A911 is the command for load 11 into the accumulator, and then store it into 210B as follows. So you can actually kind of look around for places that you can jam your code. If you just keep in mind that A9 is the opcode for load the accumulator and 8D is the code for store into a register, you can just kind of browse around and look for places that you think are not that important. Here's a really good one. It's doing a load 0 and then storing it into 21OC. So if you wanted to, you can just figure out that this 00 is at let's see, 0, 1, 2, 3, 4, 5, 6. So it's at 8916, and change that out to be a 1, and then change 891A out to be a 33, and you'll be good to go. Rather than going through that whole process I went before, like I said, I'll just leave it up to people. I've messed around with a few places in here where you can do that, and it doesn't end up breaking the ROM. There are certainly places where you don't want to mess around because it'll kind of wreck things up. Basically, if you see A9 followed by some more interesting byte value, it's probably setting some important bits that if you mess around with that. So like A909, I probably wouldn't mess around with that. I'd prefer to find somewhere where it's just throwing a 0 or maybe just a 1 and hope it's not that important. But it's an experimental thing. If you break it, who cares? Go find another place and create a different code. It's pretty easy. So we have a code up already on the website for that. You can check it out. Steez actually used that code to run Mega Man X through an Elgato, and I don't know if you want to talk about kind of that feature at all, Steve.
Yeah. So well, first of all, one of the reasons why I like the Mega Man X code is it's two lines. It's two Game Genie codes, and there's a blurb about the Game Genie hardware in the article where Galoob released 2 revisions of the Game Genie because Nintendo kept trying to defeat it, and the first revision doesn't work on a lot of later SNES consoles. The newer revision does, but it only lets you use the top line of code and the bottom line of code, and 3 middle lines of code are just ignored. So if you want to use it like on a SNES Mini, Mega Man X was a good test thing because I just had my SNES Mini on the table, so I popped that in and I ran it into this Elgato Game Capture HD, which everybody seems to love, but it doesn't support 240p over its component. But I used your code, and it recognized it and was able to, even though you're doing the fake 480i, where it's just pushing out the 224 lines on one set of line on one field, and then the same 244 lines on the next field. The game capture software seems to, if it has some sort of retro functionality, either in its driver or its software, it's able to piece that together nicely. So there were no visual artifacts when I did this trick on the Elgato. The only problem is I don't really like the Elgato's video output. I think it's really crappy, and also it's one of those devices that triggers off the wrong edge on standard def component video. So if you have the old revision of the cables, it's like crazy jittery. So, but yeah, that's why I like the Mega Man X. It lets you use 2 codes, but and the capture device thing, like this could be helpful if you really want to play like Super Metroid and there's a Game Genie code for it to let you hack it up into 480i and it works with your capture device. I don't know. Could be useful. But yeah, I think you should go to Mega Drive stuff, Genesis stuff.
Yep, that's what I was just working on that right now. So yeah, I will pull up Exodus, which is similar to the emulator I was using for Super Nintendo, but it has kind of the same features for Genesis games. Only thing is it's buggy as hell, so if it crashes on me in the middle of this, don't be surprised. It happens. So I'm going to do Aladdin here. So the features that are kind of important here is all under this debug menu. What you can do with this is you can take a look at the Mega Drive itself, and you can poke into the video processor, look at the registers. Here's the register list. The one that ends up being important for us is 0C. What you want to do is set one of the bits there, and I would talk about it all on our blog post. I'll just kind of see if here's the link. This is a little more complicated in terms of how you're actually doing the write, but it's all explained in the blog post. And there's a quick version of it is you want to write to this register here, 0C, and you want to basically set this bit, so it's not the least significant bit this time, it's bit 1 to be a value of 1. So that means by default this register is getting set with a value of 81. If we flip that, this bit here, it will change that register to be 83. So that's the main change we want to make, is get this register to look like 83 instead of 81. So the next thing to take a look at here is you can actually, let me pull up, you can, similar to the Super Nintendo, you can inspect the hex of the ROM. Widen this up a little bit. Yeah, it's too wide. I'll just leave it there. So what we want to do here is, it's a little trickier. It doesn't have I mean, it does have breakpoints. It does have kind of the similar step-through features, but it was so buggy and giving me such a headache that I decided to kind of bypass all that. Instead, you can do what's called active disassembly. And so what you do here is basically you specify kind of where in the code you want to capture. I always kind of just look for the first segment there. You could do 4,000, you could do 8,000. I mean, it's all kind of just made up guessing. But I know that if the game is going to set some important video registers, it's going to do it early on. So I don't need to capture the whole game. So I set that, I enable it, and from there, exactly, crashed, of course. Load it back up. Try that one more time. So if now I restart the system and run it, it's going to start capturing. You can see things being recorded here. And what it's just doing underneath the hood is taking a look at those hex values that are being run and translating them into assembly for you. If I just start this game up, go to kind of a first level area. That's about all the code that I want to capture. Stop that.
So
yeah, go for it.
Okay, yeah. So you're just running a little bit of code just to gather enough of it to find out where the initialization stuff is.
Exactly.
So you can mess around with it. Okay.
Yep. And then you just you press analyze. It's going to take all that hex that it captured. Once it's done analyzing it, it'll drop a bunch of stuff here, and then you'll export it to an ASM file. It takes a little bit of time, so I've already done that ahead of time. It's right here. And you can crack this open with Notepad++. We'll let you view it really nicely. So if you, again, I recommend people kind of read the article on this, but what you end up wanting to search for is something that looks like 8C81. That is the command, or that is the word that you'll write in order to set that register 0C to 81. So find the first place that it does that is right here. So as I said, this is kind of a little bit more complicated than the SNES because it uses what's called a control port. It's this location 00C004. That is called the control port. You write words to it, and that, depending on what you write to that control port, is going to set the registers on the video processor. So you don't have direct access like you do with the SNES. You have to talk to this port. So what I've seen them do in a lot of games is load this control port address into a place like A5 and then just start writing a bunch of words to it. And one of the words it wrote was 8C81, and that's the game setting 0C to the value of 81. So we want to change that. We want to actually write 8C83 instead. Oh, this thing's freezing up on me. There we go. We would like this to say 8C83. So how do we accomplish that? I'm going to pull up the Aladdin ROM. Get rid of this disassembly. And this block of code, the analyzer kind of goes through and puts these like little breakpoints. It tells you where this chunk of code starts. So this starts really early in the ROM. It's at 33E. Let's try to find that in Exodus. So go through. There's 00033. And if you go through, you'll find 33E is right here. So that block of code starts right here. Okay, that's of course the compare command that it's starting with. So you have to scroll down a little bit until you get to that command. Back to Exodus. So 33E is here. If we scroll a little bit up, there's 8C81. So this actually starts at 000360. And with Genesis, you actually write an entire 2 bytes and not just 1 byte with a Game Genie code. So let's.
So you could change twice the amount of memory
with a single code.
Yeah, with a Genesis Game Genie.
Yep.
But it operates differently, so.
Yep. So what we want to do is kind of similar to with the SNES. This 8C81 starts at, I'll hover over the first byte in that. So 000360. We want to change that to be 8C83 instead. And if I load up this Game Genie converter, you'll see that this thing accommodates a 2 byte change. And there's your code. Now, unfortunately for Aladdin, this register gets set all over the place. If we go back to our find function and look for 8C81, it gets set again there, and there, and there, and there, and there. And actually it'll get set more times than we have enough codes for. The way I kind of deal with that is I try to figure out what are the 5 most important, and that's a little bit subjective, but general rule of thumb is that I kind of throw out this first one. I don't bother making a code for it because it gets set again so soon after that it's just not worth wasting a code there. And so I'll just yeah, go for it.
How many instances did you find of that in Aladdin? it being set?
I think I found 6 or 7.
Okay. And so you threw away the first one.
Yeah, I threw away the first one. I mean, I don't know if that's the right way to go about it, honestly. It works. I don't know if that's generalizable, but
it works. It works, but you haven't beaten the game playing it like that, so you don't know at what point.
Yeah,
it can.
Exactly. This could be done in. I don't know where this code gets called. Is the point? So it may get called later in the game, and then all of a sudden the game switches back to 240p. But that's kind of the constraints of using the Game Genie is you get 5 rights and that's it. But at least for our purposes, what we want to do is have the game start up in 480i mode. As long as we can accomplish that, we're kind of okay because that allows us to do the debugging functions that we're trying to get out of it.
Yeah.
Now, if you go back to what Steve was talking about with the Mega Man X, running it through an Elgato, that may cause you some problems. You could be playing Mega Man X and streaming it, and you missed some version later on where it gets set, and all of a sudden the game flips back into 240p, and the Elgato craps out because it doesn't recognize it anymore. So that's kind of the issue there. But
okay. So a couple questions.
Sure.
I'll do it out of order because so does it work if I change the Game Genie code to an action replay? Action replay doesn't stop saving. I don't understand the second part, but
yeah, I don't.
you
So I mean, action replay is actually just these are action replay format, from what I understand. I've never actually used an action replay, so I don't want to say that too confidently. But from what I understand, action replay is actually just done by literally writing register or memory locations and what you want to change the value to be. So it's kind of an equivalent thing, just written differently. So you can do this with an action replay, yes, if that's what the question is.
Game Genie, you can't save games. So does that mean like you're playing NBA Jam? I think NBA Jam TE has an EEPROM in it, a double EEPROM, an E squared, for the data possibly, like your initial saving.
Mm-hmm.
And I'm assuming that this comment is saying, from Doug Lee, is saying that if you use the Game Genie on that, it won't let you properly save your data.
Okay.
But Action Replay lets you save your data.
Okay.
Do I have that right? I don't know. Well, maybe we can throw this to the other resident nerds we got on here.
Yeah, I mean, I don't know. I haven't messed around
more
with Game Genie enough to know. But from what I understand, you can do this exact same thing with Action Replay. You just figure out where you want to write and what you want to write at that location, and write it in the Action Replay format, and you should be fine.
Can you go back to the page that showed that register for the VDP?
For the Genesis?
For the Genesis, yeah.
Sure.
Because there's a question about Sonic 2, and I kind of wanted you to show about the couple different interlace modes.
Yeah.
Because his question was, would this be able to be used on Sonic 2 to make it work on the FrameMeister? And I don't think in Sonic 2 specific case that would work because the other interlace mode 2.
Right. Okay. So this is that mode register. We kind of glossed over this in going over it, but the interlace versus progressive functionality is actually set by bits 1 and 2. and here are the options for it. So if you set these two to 0, 0, that's going to be your standard progressive 240p game. What we were doing was setting it to 0, 1, which is that fake interlace style that we used in the Super Nintendo. So exactly the same thing, bouncing the data back and forth. And what Sonic 2 uses is this 1, 1 mode, which is the double resolution, where you actually have real 480i.
Yeah, so the double resolution, like if you just took that and if you set that to not interlaced, I think all your graphics boundaries are going to get all screwy and janky, and it's not going to look right at all. The whole point of the Sonic 2 mode is it's getting double the vertical resolution so you can fit that much on the screen. What we've been doing is just keeping the same graphics area, the writable area for the graphics processor, but we're just telling the hardware, hey, instead of outputting a 240p sync pattern, just change it up a bit and output a 480i sync pattern so the TV interprets it differently. So if there is a Genesis game that uses interlace mode 1, we could reverse that. Do you know if that Yeast game does that? Did you look that up?
I didn't. No, I'm not sure. We could do some research but later on that. But yeah, I don't know. The way with the Street Combat game that I mentioned, that's is actually in a fake interlace mode. It's not in the double resolution interlace mode on SNES. And so that's why we can fix that. You can go through and stop those registers from getting loaded with fake interlace mode. And I don't know if Voltar's had a chance. I sent him the patch so that he could test it out and see how it looks. I haven't done it yet.
Okay. Was that patch a small enough to do Game Genie, or did you like go into a subroutine to change that stuff?
It's small enough to do in Game Genie. It's 3 codes for Street Combat.
Okay.
And man, that game is terrible. Oh my god, it's straight garbage.
Why was he playing that?
I have no idea. So maybe I'll...
Zero Tolerance is 480i.
Zero Tolerance?
Yeah, do you have that?
No, what is that for?
I'm assuming it's for Genesis.
I've never even heard of that game.
Okay, so what's next?
I mean, that's it, really. I don't have anything besides that. I kind of covered everything that I wanted to. I guess the plan now is if anyone had anything they wanted to see, I could do that, but otherwise, I'm all out of stuff.
What happens if you did do Sonic 2 and put it in non-interlaced, just so we could see how janky it becomes?
I don't know. We could try. I don't know if I have that ROM extracted still. I might still have it. No, I don't have it right now. Sorry. I have to run downstairs and grab the cart. I have no idea how many times it sets that interlace mode or where it does.
It's got to be like as it's transitioning to the versus mode.
Right. Yeah, I know. It's just a matter of where that code lives. I'm not sure. It might be kind of far down in the ROM. It might take a little longer time. I mean, I could.
Can you not tell it to start dumping later? You have to do it as the game powers on.
No, you could set the boundaries. I just don't know where the right place to set the boundaries would be.
I'm not talking about in terms of time, not like spotting code it's running. Like if you like right before you're about to hit versus mode, you hit like dump.
Yeah, that might work.
That doesn't work.
It might.
Yeah.
I mean, if I can mess around with it and kind of post results or something at some point. But I'm pretty sure it would just be all goofed up.
Yeah, yeah. I mean, we've done the
opposite.
The opposite.
Where we tried to set something into the real 480i mode, and it just turns everything into a big mess.
Yeah. Because we have our test software that we use for our testing. We use interlace mode 1, but I remember seeing interlace mode 2 and trying it out with just leaving the graphics how it is, and when you do it, it's really weird. Everything's all over the place. It doesn't even, you can't even like tell what it's doing, like why it patterns up like that. It's weird.
Well, cool. I think we can call it a stream now.
Yeah, I guess so.
It's good to have all that recorded for posterity. Put it on the YouTubes. People are too lazy to read.
Cool. Is there any other quick questions about anything?
Well, if not, thanks to everyone for coming. Appreciate it. Hope this was informative or useful to somebody. I'm kind of hoping somebody goes out there and finds some other settings to mess around with and do cool things and make the game something interesting.
Yep.
All right, thanks everyone.